subset of guards, let's say for this guy, subset of guards, so that if for this junction for VI, so that if a guard is in this region, it sees at least one path that leads to VI. So it's part of the sky. Here is alpha of V1, which you store as an, my idea was to store it as a binary image. Maybe there are better ways.
That's V1, not V0?
That's VI, that's a vertex.
That's a vertex?
Junction.
So, okay.
So that's alpha of VI. And
yeah,
that's alpha of J. So here is VI.
So it's really, so so you could do BSF kind of on it. However, I most struggle is to.
I didn't finish.
Ah.
I'm not done.
Yeah. Okay. Yeah.
So that was for VI. That's S17. We have V's of S17 with -1. And let's abuse notation. Alpha of S17
Right. So I kind of have to understand the idea, but I'm still struggling. How do I get F0? How do I get the first street? How do I pick the first street, actually?
If you are at this point, what is for what would be VK? That would be S18.
Right.
What is VK?
So
we'll move.
Yeah.
So
maybe at the end of the day, it's still.
What is VK?
What's it? What's that?
What is VK?
That would be the intersection of the other two. Is that VK on the ground or is it in the sky? What are we looking at?
VK is a junction.
It's a junction. Oh, this is on the ground. Yeah, that's the intersection of the two streets where they come together.
No.
No?
No.
Now I'm lost.
We have alpha of S17.
What's alpha mean? I'm sorry. What? V17.
So a guard is in
Oh, G has to see all the way from F0.
Mm-hmm.
Is that possible? Because you will have multiple guards, right? By the time you get to VI, wouldn't you have F0, F1, F2?
I'm still in the definition of F1. When I'll be done creating F1s, then I'll start with
okay,
it.
I see. Okay. This is a path from.
So repeat my question. What is alpha of VK?
Why is that? What? Then if you do it that way, you kind of like K-1 and intercept the new visibility. I'm a little lost with the symbol now. Oh, the street, the plus. But you also have alpha with the. What symbol is that? Beta?
Yes.
So what does this mean? Also the same thing?
Yeah, I just abuse notation. I said that since the straight is directed, a guard here sees all the way from the top, all the way including S18.
Okay.
S17 all the way including S17. So alpha of VK will be?
That's an I. Is that 17?
That's VI and that's VG.
Oh,
so
okay.
That's
all right.
VG.
I see. Oh, okay. Is that true? So, I'm a little slow. Why is that just? Why is this alpha beta equal
Well, if it made sense for S17,
Mm-hmm.
what do I need to be S17? I need to see at least one street that leads up to VI,
Right.
and I also see V17.
Well, we're intercepting the visibility versus a set. This is. Oh, okay. I see. Yeah. Okay.
You get it?
Seems right.
So
you accumulatively.
A guard here sees S18.
Yeah.
And maybe also sees this street.
Right. So.
Or this street, or maybe both. I don't get.
Slowly constructing
the
intercepting visibility.
A guard here sees this.
So
A guard here maybe sees this. So what is alpha of VK?
Alpha what?
VK.
Alpha VK? And it's still, oh, from this. This is a path from. So wouldn't it be almost like union of the two?
Excellent.
Yeah.
So alpha vk is this union this, and if this street is going, let's say that this street going this direction, that's why I needed it to be a dot. If this street goes this direction, then it's this union this, union
Right,
this.
and then it ultimately point back to the linear programming problem. Because ultimately, you have to select a path. I mean, you can construct all of those sets, but you've got so many ways to get from the top
But
to
I don't
even beyond.
count. I don't care what the path is. I care, are you in the SI or not?
Are you what?
In the correct SI or not? And the rest of the operation are intersections. Now, we might turn out that we want to do the intersection using the which buffers? I mentioned it earlier.
What?
Using which buffer of the GPU?
Oh, the
Accumulation buffer or the stencil buffer might work between it CS images, maybe with CUDA. Maybe we'll store it by storing the sky and do quad trees. Maybe we'll do the sky and have a quad tree, but intersection between the quad trees will still use Bloom filters that tells us the intersect over here, so go search it. So how do I handle these operations? How do I do the intersections? How do I represent the shape? We have various ways to intersect, to represent the shape. Quad tree, bitmap, hashing, probably what would be the quickest practically. What might be the quickest would be, we have two grids, one with low resolution, one with high resolution, with intersecting the.
Yeah, we talked about.
We can go to the high.
We talked about having
there is a million ways, but that's essentially the operation.
The calculation though could get a little tricky. So we gotta.
Beside computing the spot?
Well, to try to determine the Bloom filter in the reverse direction, to try to determine the probability blockage.
That's. I didn't even explain to. I didn't fully explain to myself, so. I can tell you why that I think that if I have two nodes of two quadtrays and I want to compute the union or the intersection or whatever, I can look at the signature of the two nodes and then it tells me there is good chance that they intersect or not because they are Bloom filter is similar. And the Bloom might be only 64. But it's a separate opera. Right now it's all just using operation between images.
Right.
Now, if it's not urban, but it's a terrain, we can ask what will replace a nice description, like maxima of points, maybe is because I can see the top of the mountain and it might be good enough set. Or, but and we still didn't discuss computing the reverse visibility, but at least did we agree now after, so I'm exploring the map BFS wise, and the idea is that because I'm working with these images at the moment, at least as long as I pretend that intersection and union are fast, I can do, as long as I have enough many pixels, so intersection and union are in constant time. Yeah, that I don't need to limit the number of the positions of guards. The guards are, or every pixel is a potential guard. That's fine with me, and and later on I studied what are good guards by this intersection in units.
Right. I think what I'm going to try to do is write some test program to try to make sure that the intersection and union are really taking advantage of the GPU before I get because my code, I have so much code in there, it's hard to distinguish what is running on what.
Yeah. Now, to try Franklin code on GPU doesn't make sense to me, I think. Either we will think about parallelizing it, we can parallelize it by shooting in all directions at the same time. That's one way. Or think about triangulation, or think that out of the whole mountains, that the mountains are represented by triangles, and the V's minus one maybe I can compute really fast with just a few triangles.
One of the problem is if there's any dependency of the steps, then if you parallelize it won't really work. So.
No, but the way he did it, if I shoot in this way and I shoot in this direction, he doesn't update the data structure.
Except he was getting the highest slope, I think. Try to find the biggest obstacle along the way. So he's finding the maximum, and so if you.
So that's pre-processing of the terrain that you can do before you start looking at the terrain.
What's that?
That's pre-processing of the terrain that you can do. It's not guard dependent.
Right. So that definitely, yeah. So just gotta figure out what part of logic can be, because right now, I mean, the visibility itself is running so slow in the GPU. It's not helping. So I'll have to modify the algorithm.
The GPU, if at all, it made for these operations. It made for triangulated terrain, not for DIM.
Oh, okay.
But with DIM, you lost most of the advantage. Well, you still got parallelization, but the hardware is made to render triangles. So
that's true. Yes. So then, how do I get around that problem?
It's not. Well, to triangulate the terrain, there is plenty of code. If we want. At the moment, you're just saying that the running time, that's not part of the running time that you're counting. But let's figure out for a straight. I mean, a straight, I mean also a valley, a river, a ridge on the mountain.
Yeah.
So it could be many other things, but at least for the case of a street in the city, let's understand what's the relationship. So you have the visibility region of the two endpoints. You intersect, it could have multiple intersection points. Intersection region, because it's not convex polygons, so it could have lots of intersections. Out of them, you care for the one that contains a street to start with, but you're right that there is one piece that I care for, that I still need to filter some things. But so it's roughly the component that you're operating by the intersections of the two, minus some things on the side.
So I'm struggling with how do I calculate the visibility of the entire, for the street, because like I said earlier, I have to check every point.
No. So once again, it's only the endpoint that you're checking, but there should be something that you do need to clean out.
But even if I only check the endpoint, I still need to increment one at a time to get to the endpoint, because I don't know where the endpoint is.
I mean, I assume that the street is given as a map with junction and edges. Otherwise, we pre-process everything.
Okay, I see what you're saying.
Yeah, that's not.
So I can pre-process and map all the streets. That's what you're suggesting, right?
We'll get there now, and we'll get the building in original. And you agree that it's at least that if I have the visibility from the endpoint quickly, minus the case, I'll go to bring my Lego thingy. You are saying that it could be that I'm running into this part of my triangle, and my intuition, which is wrong, was that then if I'm running into something and I'm moving it, and now I can enter, then this part will be on the just on the boundary between visibility and non-visibility.
Right.
So, but it's not entirely true. So it should be something like, I think here is the street, VI, VJ. Here are the region, as we said. They have so there could be more connected components, maybe from the connected components I cared about the intersection, so I need the intersection actually to contain this part. And it's the intersection of what I see from here, intersection with what I see from here, and what I see from here is, of course, so it could be set of edges here, set of edges here, and an edge here, of course. I look at the intersection of the two, but to this point I see and I think that you said correctly that you want to know something about this angle here, if I can squeeze a triangle or not.
Right.
Which is a clever thing to say.
So if we use the, if we just use the chord tree and just use the regular visibility, couldn't we try to figure out and the bloom filter, we could at least benchmark how much time saving we are, how much faster the algorithm is. Don't have to go to reverse visibility, do we?
In a triangulated terrain, the reverse visibility should be really, really, really quickly, because you are pushing one triangle at a time and you are progressing just from these two endpoints. So it's only on the sky, it's only one connected component from each endpoint. So it should be way faster. Now, why only on the sky and not on the mountain around? I mean, everything that I said works for multiple connected, just that will be harder for the mountain. So we are not comparing the same thing.
So because I couldn't tell whether I can see the entire street, that's why in my current code I'm pushing 1 pixel at a time, which is extremely slow. So if I pre-process the street, maybe I could say within a certain threshold, like use the robotic type of approach. Like if I have a robot, can I walk straight whichever angle?
No,
but it
even
doesn't
if
have.
you're seeing it for multiple points, all you're saying is you're asking what do I see of the sky, and you give it a color for each one, and you're just
Right.
repeating it. So it's a standard exercise in graphics, and now you're asking for a pixel. Did I accumulate enough colors? I actually think that we can, a lot of this BFS we can do in parallel as well, but I don't think that it's a hard problem. I think that we right, let's do an exercise. Everything okay? You look a bit you look a bit less than happy today. Everything
I didn't
okay?
sleep very well last night. I was
So
really sleepy today.
So now let's continue tomorrow. We don't.
No, sorry. Yeah.
You're sure?
Yeah, I'm fine. I just
Okay. So
I'm a little slower today because I didn't sleep well.
mood-wise, mood-wise, everything okay?
Yeah. Other than that, everything's fine.
So here's the two endpoints, and I don't want to destroy this page, but I'll take a stub that is just this straight.
Mm-hmm.
And out of all these points, I want to know what is the one that limits this slab. What is the first one when I'm going from the straight to this direction? And let's say that that's the point that, the first point that I hit.
Right. So we can use a hyperplane.
So now you want to ask me if. So it tells you that all the triangles up to this angle all the triangles up to the critical angle are happy, no matter where their endpoints. Definitely when I'm, let's talk about this, the orthogonal direction of the street, just because I'm not smart enough. So it's not here, it's not here, it's this direction. I hit a point, and I don't know if it limits, if it killed all the triangles. It definitely killed at least one of them.
Mm-hmm.
No, killed, like if I try to squeeze more, it will kill at least one of them. If it didn't, and that's the first point in the whole part. If it didn't, then I'm only asking for triangle from here to here. That is that above the two endpoints of the street. So either that it's a critical point, it's the first one implying that if I'll go from one triangle to another, this is either limits by the same point or general position. It's there are no points beside this one that limits it, because I don't have two points with exactly the same height, and that's the original one. So I think that if there is any chance for a triangle here that will go, then this will be exactly on the visibility region. So a region in the visibility of the sky, that must be an edge of this endpoint. I'm very much relying heavily that general position. There is only a single point that limits it. So so this is a point that limits
no
this
parallel,
triangle, and if I'm just passing from this point in the y direction, which I'm not sure, the next one is this point. That limits, but from here to until this point starts to interfering, from this angle to this angle, this in the sky should create an edge. And this intersection of the edge of the two regions will have this edge, so just a portion of the edge.
The calculation to find that point, so almost you do the transformation, keep drawing a hyperplane until you hit something.
Well, you're just checking the slope of every point in CPO. Now, if you are doing it all in pushing shaders one after the other, but for this then you'll find it much quicker, because it will appear in the image that you're generating in the depth buffer. Yeah, it's not a full algorithm, but I think that it will work. That is, I think that if we are looking carefully on the edges of the two visibility regions, we will discover the trace of this point. But why? Because this point, if I'm just moving away a bit from it,
So that point lies on the edge of both regions.
It's on the edge of one and inside the other, I think. So that's for urban streets. Now, if what I have my idea, but I want to hear from you is, look at the mountains, tell me what are good set of roads that would be nice to use then, like replace a road. So this can be a street, but maybe it's a ridge of a mountain, and then I'm exploring the maybe, or like I know I started to play with myself that when I have mountain in front of me, if I would need to declare a path that I'm guarding, what would I guard? Like so. see a mountain and place them like here is a very bad example. I visited it and tried to decide there. So this slide, yeah, not much to pick here beside the wadis, but with the, yeah, but for more well-behaved mountains.
Let's say if let's say we randomly pick points on the terrain, we're back to how our normal visibility also works. Let's say if I pick a point from each one of this square, so I'm gonna end up having similar stuff like I had before, right? Couldn't I could still use the BSF and just try to pick the best minimum number of guards? Like if
I have a proposal.
Huh?
I have a proposal.
Yeah.
Let's start speaking about the whole project as that each part we know how to do optimally, like that we can start with, like in the direct visibility, not the inverse, that we have good ways to pick guards, and maybe we have AI that help us improve guards that we already picked, and assuming that we are perfect. Or alternatively, that we don't want to pick guards, but we have the sky and we pick from them. Or that we have fantastic intersection between them. And again, and I want you to tell me ideas about how to find to connect the two faces, the two-sided ones that would be another reasons for the GPU. But that each one, like thinking about this and BFS, like you want to speak about direct visibility, not sky, not
even
reverse.
in the sky, doesn't it still end up looking like that? If the position of the points on the terrain are fixed.
Which point? Guards?
No, these are terrain locations.
Okay, that's elevation?
Yeah.
Okay.
So it will still end up looking like that. So let's say if I write, if I have streets, you know, like assuming that these are the streets, it will still end up looking like we had before. And then an IOP or BSF will still give you the best solution. Because each one of the circle means I look up, I can see this area. So, but that's different. No, I mean you could save some by I'm only picking intersection, because the old method you need two guards. Each ball is a guard. Now the new method is if I pick one is in the intersection of multiple guards, and I save one guard by picking this guard position, and then I pick this one, I save two guards. That's pretty cool.
I'm entirely lost.
Because by looking up the reverse direction, I can tell the space.
I didn't understand what you're saying.
Oh. I'm not sure if I'm thinking right yet. But if I'm doing reverse position, let's say, I have 9 positions. and I have 9 visibility regions that have some overlapping. So in the old ways, we could say we pick from north to south. Well, here is only 3 though. But then, yeah, I guess I'm still not really saving. Never mind. I just thought that if I pick the intersection of 2 of the street, then I could pick better positions. Yeah, because I could pick a guard here and a guard here. This guy will see all the way from, from north to here, and this guy will see from here to here. That means I only need 2 guards instead of 3. The original visibility, I'll have to pick 3 guards.
We need a title. What are you suggesting?
By
Are
looking
you
at
suggesting a new algorithm?
No, I'm just saying by looking at reverse visibility, not even thinking the street, just thinking of, I put the points, yeah. Then I can see what are the feasible guard locations. Consider that instead of my visibility location. I can look into the feasible guard locations. By looking at the feasible guard location, then I can prune some of the guards. Like I can put a guard right in the middle of, like an intersection of the 2 alpha regions.
They are connected with us. Yeah, I don't fully understand. I need to think about it because now. Is this for the endpoints of the street? Is this a straight map?
Not really. It's just, it could be anything. Just points on the ground. But yeah, street is better because then I'm guaranteed the whole street is visible. I guess I should call it street. Yeah, let's see if it is the street. That makes more sense. Street. So I have a street, and a street, and a street. So from a street, I have a alpha region, something like that.
I was debating about the AI project. It's interesting. I don't know if we want to. It's interesting for me a bit, but that when we are looking at the terrain and we want to ask if 2 guards is the same area, it would be nice to pick points on the terrain that are good indicator of do they see or not see, or how much overlap there are. Is one add a lot, and it would be nice even to use machine learning to say, I'll give you a terrain and give me a good of feature points that they are indication of both intersection and how much intersection and so I can give it a bunch of pieces of the terrain that I do know and ask what's the best point for this one, and then if there are anything that can transfer to pieces of the terrain that it didn't see. So that's a very
That is why when I did the machine learning, I make that one of the reward is the connectedness. How many, like, I was trying to move the guard, but I want to optimize. One of the optimization parameters to optimize the number of connected intersections.
yeah.
But I didn't get a better answer, but that could be because I didn't run it enough time because it takes too long to run.
Yeah. So it's a little project that I thought that machine learning should have better answer here.
It did
here is the terrain, what you will have plenty of points, and instead of giving me the full visibility, just tell me if you see. I'll tell you in this picture, here are my waypoints and they are good classifier. Even though I didn't, I have only one picture of the way. That's what I need to see from other pictures. And that's something that maybe you can train.
The machine learning did give me a better answer, even though it beats my BSF that I started with. I also implemented a variation of it.
It's much simpler question. It's just to say, I'm going to run a bunch of guards about this for various different reasons, like connectivity. And for this, I need to ask if two guards see a lot of the region together, or see the same region. And I want to say that my first guard will have some intelligence to say that a point that is locally optimum, say, is a good indicator if two guards see this point, and the visibility overlap to start with.
Right.
But so how do I pick? So I want to ask how large is a visibility region between two guards. I'll ask among the small set of witness points, which one of you do you see? But what is the small set of witness points? We want to have, that's something that I think that we can have in machines learning. I don't know if it's new, but it should be.
So you're talking about maximizing the.
Just as a prediction of, there are a few things that I care about, visibility of intersection.
Visibility of
I
the.
cared about if
the
now
area.
it's normal visibility.
The area.
I cared about do they intersect at all, and for all the things, if this is a region of 1 and that's a region of 2, then maybe I don't care that much. I would much rather be. So I cared about both this minus this, and I cared about other parameter like this minus this, or this minus this, or this. A minus this. B normalized by area. I don't know area of what. Instead of first computing the visibility and then to check, it would be nice if you tell me, here are 10 points in each region, and if out of the 10, none is common, the 10 here and 10 here, none is common, then I'll guesstimate that they don't intersect at all, and if you see where it's going, and if they do intersect, then these parameters give me. But how do we pick good points in each region? And now when you tell me what are good points, I'll say, fine, I'll pre-process the whole terrain to pick this point because AI will tell me these are good points, and now for each guard I just ask, do you see these points or not? Because they are good predictor.
That's a good idea.
Maybe that's sound like something that Franklin might have tried in some way or another, which I can promise to contact him. So I should that I don't know if he called it this way, but
right now,
yeah, just a shortage. That's like classical feature selection.
Yeah, one of my methods is because the cost number of connected components ultimately is needed is depending on the initial position of the guard. So I used the trick that Jason taught during class of clustering. It's like to randomly initialize the guard position. I mean, within the cell, the grid. Like, let's say if I have a square uniform, I move it around inside.
That's one common method. Another one that probably also mentioned is pick the first one at random. Pick the second one as far away from the first.
Yeah.
Pick the third one as far away from the first. Yeah. Both are.
When I did that, the one that I started with 9 connected components went to 7. Improved it. When I didn't randomly initialize, it could get to 8, but then when I randomly initialized, I got to 7. So I saved 2 connected components. I should try that. Find the value points and then throw those first few points in those valleys.
I don't know that it's publishable research-wise as is. It is that if you're using a package that try to solve sweeping, and they want to solve sweeping, but they are optimizing something else. And if you want it to you can say, if you want something publishable, something part of the theory, so I would think that anything with connected components that you are looking at yourself and try to move, but to meet your optimization function. Right now, I'm afraid that, at least from your explanation, I don't know that it's built to help us, it's built for other problems. So,
Problem is, it's not interesting in terms of geometric algorithm. It's more a machine learning type of.
I'm very happy with either.
Yeah. That's just for the project.
Yeah. No. To move them, if you can tell me, I know that they are moving in a way that increase the number of connected components or smaller the numbers or try to get rid of guards.
Mm-hmm.
And you know how it works, and you're saying I'm sure that's what the algorithm is doing, then it's all fine. Yeah, so I didn't mean it to sound as a criticism as a whole. I just got nervous of using a package that is like, it's like I got TurboTax and it doesn't compute guards very well but it's not. That's not what TurboTax is supposed to do. Funny why I thought about it.
Yeah. Right. So
I used pie charts that it has all the optimization I think in the world of MATLAB or nothing but. Now the idea of removing a guard and maybe adding another one. I had some vague idea about checking if another guard can close a cycle and can add another. Can tell you that I'm checking with a set of guards, what do I see? And then I'm asking, can I add a guard and remove a guard? Which now I start to think maybe I can check it with a flow without running from scratch. This is the idea of local search. Just what can I gain by replacing one guard with another?
But the problem is still I have to find the location. You know, we place it with another guard, but where do I put it? That takes a lot of moving around.
No, you're placing with another guard that you know its location. If you're using the guard, then you're getting all the connected components. Assuming, the assumption is that you have a set of images. For each image is all the connected component of each guard. So now, if you're asking in the graph, how do I know if I can remove somebody and somebody?
That's a tough one because you don't know until you run a BSF or almost.
I'm not sure, but
or maybe you could. Actually, no. Actually,
I'm not sure, but I don't know. That ST will know because ST played with. If you did add somebody that, well, that's the direction of the edges, but in a sense, I look at all the connected components. Once I use this graph, this guard, I get all its connected components for free. And I want to ask if there is a flow now that form a cycle. Maybe it doesn't. I don't know
no, the BSF would have taken care of that if there's a cycle.
BFS will not. But BFS will not.
If there's a cycle, the BSF always pick the shortest.
Right, but you're solving it with flow. The ILP solve it with flow.
BSF doesn't, right?
BFS doesn't.
Right.
The ILP does.
Right.
But I don't. But the ILP, we know that will choke. It will try larger input. So.
Right.
But so that's why I think about still to think about it as flow. And to say, I'll have a BFS that tells me with this set of guards, how far away can I reach? And now I wonder, can I drop one guard and add guard and reach a bit further?
Right.
You like it as a bit lower.
Just try to figure out the position of the newly added guard is what I struggle with.
In my model, you always start with 130 something set of guards. You already computed for each one the full visibility.
You mean okay? I see.
But
Yeah.
And I started to prepare an input and didn't finish. That's a ILP. But one of the reasons that I wanted to make this input for you is to see that the ILP can have issues if I'll. So I'll start with. I think that that's a good example. So here are a set of blocks. They intersect only 1D. Okay, and there is 30 blocks here.
Mm-hmm.
And they all start at integer coordinates. And I'll call this one the red, blue, blue, yellow, yellow.
Mm-hmm.
And then I'll take a random permutation of them.
Mm-hmm.
But so I have 10 guards. 10 guards each has 3 connected components, meaning that if I pick these 3 guards.
Right.
But that's 10 guards. And now I'm throwing on top of it 10 other guards at random locations. So if you pick the correct 10 guards, then they just barely align to get it. But if you pick any other subset of guards,
isn't that similar to how I randomly initialized the guard?
Yes, but and I thought that this example would be good, but you solved it. That it should be that only if I pick a good subset, the correct subset that I have, like that, only half the subset are relevant, and there is nothing that like a key to the pin that I cannot greedily say that these 30 exactly fit and every other 30 will not. I think that something like this will work, but maybe the reasons to run it is just to have an example in mind where the ILP could work, except that it takes too much time.
Yeah. What about, I do notice, if the reach of the connector component is larger, you could potentially, have less connector component. I wonder if I'd like to try that idea, like if I put a guard with the maximum reach of a single connector component. Like I place it so that I could use the score is the long maximum size of the connector component, either the length or the width of the area. Use that as a optimization parameter to start with that, and then
to pick a few directions. That's if you want to recycle your project. But again, I'm nervous about that I don't understand the optimization. But
I'm not talking
optimizing. If you take each guard and optimizing its diameter in one of the canonical directions.
I'm not talking about machine learning at all. I'm just talking about placing the guard one at a time that way. See if I can get a better answer.
You'll probably get a better answer, but it's where I want, or I think that your time should be. I guess that it makes sense to run it for BFS, maybe. But the BFS, you think about the two-side visibility, how to do it?
Yeah.
Because when you have
I implemented some of that pairing the guards and merging and all of that. But I wasn't getting an improved solution, so I stopped doing it.
Yeah, for most terrain we will not, and I can show you why. I can show you at which position. Like you get a few, but they need to be like nicely. I convinced myself, but
but I do want to ask a question separate from what's the right solution. So right now, I forgot to show you the sheet. I have the sheet that just said these are the approaches I've already done. So we did the BSF as an approximation, and then we did the ILP, and then we did the machine learning. I have a lot of data to show, the result. Would that be good enough for paper? And then say future, we want to look at the reverse visibility and.
Probably not. So take will fine, but and again we can use the time that you are doing the machine learning to get useful things for the paper its own. And all in favor, either using the packages but understand more about the package and what they are trying. And if we can isolate things that, in terms of input, I think that we need to go to way larger input, and just to do the BFS. I mean, in a sense, you want to ask what's the coolest way, or the cleverest way to do it, even if it's not like a bunch of hacks that said, sure, that's improved, but I cannot prove anything about it. Like the projection on a few directions, I thought that then maybe I can prove that with some assumptions that some approximation to the opt. But for friendly terrain, if the terrain is like hills but not cliffs, that there is a maximum slope, then maybe we can say something. In terms of input size for all the algorithms, I would encourage people to think about if beyond what hex of can do, if I have a really large, if that's my input, and
right.
Yeah. I don't know to tell you what's the right number that we need to solve, but I'll tell you. For example, colleague of who should be on YouTube now. There is a ex-postdoc of Joe just found an algorithm that I think find optimum triangulation. That we studied in class what is triangulation. I think that he's talking about one of the minimum angle or something, something that is NP hard, but there are methods to try. and he has a paper now about it that they solved it 4 billion points, 10 to the 9. So that's like, yeah, so I'm not saying that that's what we need, but 6, 7 regions and simple terrain will not. It's which tricks we are coming up with more than
well,
quick homework. Check out for accumulating buffer if it makes sense. Is an advantage comparing to CUDA. And accumulating buffer, stencil buffer is another term you want to look at because they are implemented in hardware. And you can also look for visibility problems on that's in the theory world in realistic terrain.
On what?
Realistic.
Oh yeah, I wrote
people that say terrains are not trying to. There are a million models that tries to say formality here is a nice terrain, and lots of people work about it, including real model of realistic. So this and a bit about buffers and working straight with the GPU. Again, I might be wrong, and it doesn't really give the same improvement that I thought that it gives.
Well, do we want
now, what else will give is that we have all the theory discussion about the 2 guards, 2 sides, and how to do it even for a polygon that I need to discuss with you, and that's much more theoretical.
we want to process much